Okay, welcome to the Feedback Prize English Language Learning First Place Winners Call. And Natalie, I'll turn it over to you to start introductions. Awesome.
Yeah, thanks, Maggie. Hi, everyone. My name is Natalie. I'm a program manager with the Learning Agency Lab, and I will pass to Alex.
Hey, everyone. I'm Alex. I'm a data analyst of the Learning Agency Lab, and I'll pass to Perpetual.
Hi, everyone. My name is Perpetual. I'm the research director at the Learning Agency Lab. I'll pass to Scott.
Hey, everybody. My name is Scott Crossley. I'm a data scientist at Vanderbilt University.
Yeah, hello, everyone. My name is Rohit Singh. I am from Pune, India. And this is my first time presenting a solution to this competition. So, yeah, now I'll pass to Yevhenii.
Hi, everyone. I'm Yevhenii, or Eugene. I'm a data scientist at Fractal, and I'm, be nice to be here. It's nice to be here. Sorry, my language is bad.
Great, so you can start presenting your slides. Yeah, go ahead.
Yeah, just give me a second.
Great.
Yeah, am I visible to all? Yeah, hello, everyone. So my name is Rohit Singh, and today I'll be presenting our team's winning solution. Our team name was AutoX and Rohit and Yevhenii. First of all, I'll give a brief background what we are doing today. A brief set the agenda of this call. So first we will explain a brief background of our team, and then we'll proceed towards the summary of our solution, explaining feature engineering and selection part. Later on, we will move to our training methodology, our interesting findings, and at last our simple solution. So hello everyone again. My name is Rohit Singh. I am from Pune, India. I have done my graduations.
Rohit, is there any way you could share full screen or make this full screen?
Yeah, just a second.
Thank you.
Is it fine now?
Yep, good, thank you.
Yeah. So I've done my graduations in computer science, and I am currently working as a lead ML engineer in a legal tech startup in India. I have close to 6 years of experience in ML engineering, and this is my first time presenting a solution. Okay, now I'll move to Yev. Yev, you would like to give a brief introduction of yourself?
Yeah, sure. So I have a bachelor degree in computer science, and currently, as I mentioned, I am working as a data scientist in Fractal. So I have 1 full year of experience, and it was my third competition, I think. So that's all.
Yeah, great. Since Portman is not here, I'm just moving to the summary part of our solution. So our solution consists of these following 6 parts. First, we did some pre-processing, followed by our pseudo labeling part, then some training methodologies, then we figure out some fine tuning, and at last our final ensemble. So let's start with the pre-processing. So while doing ED earlier in this competition, we figure out that there were few placeholders were present in the essay text. So what we did, we replaced these placeholders with some specialized tokens, like generic underscore school was replaced with this specialized token named generic underscore school. And at last, we replaced the \n new line token with BR token. So we figure out that there are 16 such placeholders. So we replaced these 16 placeholder text with their custom tokens, and then we added them to a tokenizer. Post this, I go through my pseudo labeling part. So in order to do pseudo labeling, we used both feedback 1 competition data and feedback 2 competition data. So what we did is we merged both these data, both the trained data from both these competitions, and removed all the duplicate entries from there. And then we train few models on our trained data of this competition and generate pseudo labels on previous competition data based on that models. We also have pseudo label generate for this competition data as well. Now I'll come to our training methodology. So our training pipeline is most of all similar for all of the models we train, with some exceptions, like we use train data / pseudo label data initially, and then we implemented some pre-processing part, followed by some tokenized truncation. Like we limited max length to 1422 tokens for few models, and few models it was limited to 768 and 512. And later on, I'll explain the model architecture. Model architecture is almost same for most of the models. So we pick a base transformer model, and then we applied some pooling techniques on top of it, and at last we reinitialize the last layer of every model. And the training part involves freezing some bottom layers. Like if we have 12 layers in our model, so we freeze almost 6 of the bottom layers, and then only fine tune the last 6 layers. We also use differential learning rate. What differential learning rate means here is the learning rate used for our head is slightly bigger than the rest of the embedding layers. We also used AWP. AWP means adversarial weight permutation, which gives us nice and robust solution for this. Here are the list of models which we used for this competition. We are mainly restricted to 6 base models, which include Deberta V3 base, Deberta V3 large, Deberta V2X large, Roberta large, Distilbert base uncased, and BART large. And along with that, the pooling techniques we used are mean pooling, concat pooling, weighted pooling, and gen pooling. So most of our models are trained in 2 steps. First, we pre-train our models on pseudo label data, which we generated earlier. So what we did is, in order to train our pseudo label models, we kept the batch size very small. Like it was in the range of 3 to 6 for most of our models. And while fine-tuning on train competition data, what we did is we tried to fit as much batch size as we can. So it was generally ranging from 8 to 24 for this competition data. We also generate pseudo labels for feedback 3 competition data. And along with that, there was one further pseudo labeling part where we took the true labels from feedback 3 competition data and take the average feedback 3 data, and the pseudo label we generated, we take the average of those two and took it as our true label for further training. Or here it comes to the ensembling part. So what we figure out that when we try ensembling at model level, we were getting boost, but that boost was not as much as compared to what we got when we assembled using column wise weighted ensemble. So what we did is we first make predictions of all our models for each of the target, and then we find individual weights of all of our models, and then we combine them. So at the end, we have 108 weights. So total we have 18 models in our ensemble and 6 targets. So 18 weights per target, which calculated equal to 108 weights. So for weight optimization, we used Optuna. And here is a brief overview of all of our models. So this model column represent the model we train along with the pooling type, along with the trained on. So trained on explains what the data is used to train that model. So here PCP denotes previous competition pseudo labels, and CCT denotes current competition train data. Along with that, there is one more data, CCP, which indicates current competition pseudo labels. So as you can see, there is a list of all the models we trained. So apart from them, model 52 was the best model which we got. It has the best CV of 0.440, and the private LB was also very good, which was 0.434. Apart from that, there were 3 models which were not trained on any data. What we did is we just extracted embeddings from them and then trained a simple SVR model, which is support vector regression on top of it. So last 3 models, FP-BART large, add V3 Roberta large, and FP-BART large MNI, were just, we use them just for extracting embeddings and then just simply training SVR on top of that. So all of our 15 models were trained on 5 folds, and last 3 models were trained on 25 folds. Here is the model importance chart. So as you can see, model 23, which we trained earlier, has the best importance among all of our models, and experiment 14 FB3 Roberta large model, which we trained, it has the least importance. So now I'll share some interesting findings from this competition. So from first of our experiments, we just came to conclusion that pseudo labels were helping a lot. So what we did is we pre-train on pseudo labels, and then we mostly try to fine tune on this competition data, which gives us significant boost. Also, while creating pseudo labels on trained data, we discovered that if we generate pseudo label on training data, and then if we train a model instead of taking actual training data labels and use that generated pseudo labels, the model was hugely overfitting. We were getting CV in range 0.43, but the LV was significantly worse than all other models. So what we decided is, in order to keep in, if a model will only qualify in our ensemble, if it gives us boost both in CV and LV as well. Also, we found out that model 23, which we trained earlier here, it neither has best CV or best LV, but still it has giving us most significant contribution in our ensemble. Apart from them, reproducing our final result will took around 450 hours of training on a single A6000 GPU. At last, I would like to share some findings about our simple model. So the simple model which we trained was Roberta V3 large, and the experiment name was model 52. And by training this simple model, we were able to qualify in top 10 of the leaderboard, and the inference time was significantly reduced to 25 minutes from 8 hours, which was the inference time of our whole ensemble. The CV score we achieved for this model was around 0.44, and the LB score we achieved was 0.43. So let me explain more about how this model was trained. In order to train this model, what we did is we almost took all of our previously 14 trained models, and we regenerated pseudo labels using ensemble of those 14 models. And the final ensemble CV we got was 4419, and then we took this pseudo label with CV 4419, and then finally trained a model Roberta V3 large, and this was considered as a best model. So while pre-training on pseudo labels, we kept the best size very low of best size 3, and finally while fine-tuning on trained data, we kept a large best size of 12. So I think that's it from my end. Now we are open for questions.
Thanks, Rohit. That was very interesting. I have a follow-up, maybe clarification question on the pseudo label.
Yeah, sure.
So to be clear, you did use pseudo labeling based on the feedback 1 and 2 prizes. Is that correct?
Yeah, correct.
And you say that it really helped raise your accuracy, or that it was an important component?
Yeah, it really helped us gain significant boost in both CV and LB. Yeah.
Okay. Yeah, because we've talked to other teams that said that pseudo-labeling for feedback 1 and 2 data did not help. And so,
In our case, it helps. So.
And so I was curious. I don't want to go through the code and figure out what you did different, but why might it be the case that pseudo-labeling on feedback prize data 1 and 2 was very helpful in yours, but not in
maybe what we did is while training on pseudo labeling, we kept our batch size very small. So that may be one reason it helped. And while training on this competition data, we try to fit as much data as can in our current batch.
Can you explain why the batch size would help with the pseudo labeling, making it more successful?
Yeah, would you like to explain this?
I can try at least.
Yeah.
So my idea behind a small batch size was, on first step, was to pre-train the model just to some maybe not global but local minimum of loss, and then fine-tune with batch size higher to to get to try to get to the global minimum of function. So if it's answer your question.
It does. I still don't conceptually understand completely, but I can think through it.
Okay.
And feedback prize 2 included feedback prize 1 data. So did you? So there was some repetition of essays in feedback 1 and 2. Did you just try it with feedback 1 to see if it made any difference, or did you automatically include both feedback 1 and 2?
I included both, but I filtered. I dropped duplicates from resulting dataset. So.
Okay. Perfect. And then one other question I had for you is that you replaced the PII information. So basically the information that was like school name and child name. It was like your first or second slide. Can you go back to that real fast?
Yeah.
When you created new tokens.
Yeah.
There. So explain to me why that helped, or why you needed to do that. Just so that
actually
the
model we trained doesn't have tokens for these
right.
placeholders. So adding them as a special token helped. There is nothing new in this. We took this idea from previous feedback competitions where a lot of winners did the same, and it helped us. So
okay, so you didn't replace did you remove the tokens or replace the tokens?
Replace them with the special tokens, which we added to tokenizer.
Okay, thank you.
And then added on top of it. Yep.
Okay, thank you. Those are my questions.
Were there any other data specific questions? I have a non-data specific question, but don't want to cut the data discussion short. Okay. So I'm curious to know what was appealing about this competition, why you wanted to join it, as well as once you joined, what you maybe feel like could have been done better or might be more appealing for future competitions.
Actually, most of my experience in my current company is in NLP. So this was an NLP competition. So it was exciting for me to gain knowledge out of it. And apart from this, I also joined Feedback 1 competition in which I was able to secure around 74th rank. So that was also a motivation factor for me to join this as well.
And is there anything you'd like to see done differently in future competitions?
Kaggle in its journey over past decade has improved a lot. So I don't think there is anything else I would like to contribute or give input to. Yeah.
Okay. Yeah.
Okay, so should I do the same? Answer the same question? Yeah.
Yeah.
Okay, so I participated in previous Feedback 2 competition, and I already had the pipeline to train the models, some idea behind NLP, and state-of-the-art models. So I decided to try, almost all the same, but for some more like scientific approach to modeling. At first place, I started to participate in all this competition just to learn something. I'm like love to learn. So
Yeah, thank you. And is there anything you'd like to see done differently in future competitions?
I think that my problem was that I tried to change several different things at one place and one time, and I want to have more don't know how to say it, more consistent approach to always problems, something like that.
Yeah, I think that makes sense. Thank you both. That was it from me, Maggie.
Awesome. Well, congratulations. Great first presentation, Rohit, and nice to meet you all.
Thank you.
Yeah, and thanks so much.
Yeah, we really appreciate your participation and great job. Congratulations.
Thank you, guys.
Take care.
Thanks for having us.
Okay.
All right, everybody.